these things called like radicals, and by like radicals, I don't mean like radicals, you know, like I'm talking about like radicals. I'm talking about radicals that are alike, like the same, okay? Like the real usage of the word like radicals. That's what we're talking about. So I'll show you what that means here in a second, but before we do that, let me ask you a question. If you had that, throw back to Algebra 1, and I told you to simplify that, what would you do? So combine like terms, perhaps. So you got x's, you got y's, you put all those together, right? So that's 4x, that's 9x, and that's 10y. Yes? We know how to do this, right? Not too bad. Well, what if you had this? 2 cube root of 5 plus 8 cube root of 5. They have the same index. Yep. So it's the same index. It's the same. Remember, the fancy word for that is the radicand. So that's the same. What does that mean about these things? They're the same. They're like radicals. Okay? So if you can put 3 and 5x together to get 8x, then what's 2 cube root of 5 plus 8 cube root of 5? It's 10 cube roots of 5. That's it. That's the gist of it. Okay? You're not putting these together to make like cube root of 10. That's not how it works. Cube root of 5 is some number. Like it's some gross decimal. I don't know what it is. We're just writing it as the cube root of 5. So if you put these together to make the cube root of 10, well, you've made a new number now. You've changed it. Does that make sense? So we're pretending like it's a variable. We're putting them together. And that's pretty much the gist of what we're doing today. So let me give you the kind of the official rules here. In order to add and subtract radicals, we need 2 things. Oh, I guess that works. We need the same index. So remember, that's the same type of root. So like a cube root or a square root or whatever, you need the same index. And then you also need the same radicand, which is the fancy smart person word for the number on the inside of the root. So say number inside. Yeah, so same index, that's like the type of root that you're dealing with. Is it a cube root? Is it a square root? Is it a 10th root? Whatever. So if you got those things matching and you have the number on the inside matching, you've got like radicals. So you can put them together. Okay? Once you have like radicals, this is kind of the big important statement that I think makes this make sense. We treat like radicals the same way we treat variables. So if you have like radicals, just pretend like they're variables. They act the same way. 2x plus 2x is 4x. 2 cube root of 5 plus 2 cube root of 5 is 4 cube root of 5. That makes sense? So on the last, this thing, we're adding. Oh. It's plus, so 2 plus 8 is 10, and then this is just like a variable. Okay? Is this making sense so far? Okay. All right, so a couple of quick 2 more examples. Square root of 7, square root of 7, are these the same root? Square root, right? Same radicand, yes? They're both 7. So pretend like it's a variable. What's 5 plus 3? 8. So what is this? 8 square root of 7. Wow, you guys are geniuses. Yep. Okay, what about this one? You tell me. What do you think you'd do here? Okay, so there's a 1 in front of this thing, right? So I can put these together, right? Because they're both 4th roots of 5. So 2 plus 1 is 3, so that's 3 4th root of 5. But what's going on with this thing? It's different roots. So can I combine it with this? No. You can't take 3x and 2y and make 5xy. That's not how it works, right? Exactly. Wow. You're good. So you can't do anything with this, so you just leave it on the end, just like this would be 3x and 3y, right? Just making a little bit of sense. Okay, well, yeah. So as long as you got the same index and the same number inside, you can treat it like a variable and put stuff together, add or subtract them. All right, well, not always that simple. What if they're different? Oh my gosh. Can you put these together? No, why not? They're not the same. They're not the same radicals. They're not like radicals. But there's a trick. We're not screwed if they're different. Okay, we can figure something out. We can get a little bit creative. Use some of the skills that we've developed to force them to match. Here's what you're going to do. If they have different radicins, remember that's the number on the inside. If they're different, you're going to simplify them until they match. So we're not screwed. We're not just going to give up. We're going to hang in there. We're going to use the skills that we have to figure something out. Okay? Here's what I mean. Let's do this one. What I'm going to do is I'm going to look at these things one at a time, and I'm going to simplify them. I'm going to break them up. I'm going to simplify them. And then maybe they'll match so that I can put them together. Okay? So let's look at 3 cube root of 75 first. Or sorry, not a cube root. What is this? This is square root. Yes? So if I want to simplify it, what types of numbers do I need? I need perfect squares. I'm trying to break it down. So I need perfect square numbers. Are there any perfect squares that go into 75? 25? 25 times 3? So that's 3 times the square root of 25 times 3. Yeah? So we've done a ton of these now, right? What's the square root of 25? 5. So the 5 comes out in front. Have I done anything with the 3? No, it's still there. It's 3 times 5 from the square root of 25. And then I have this square root of 3. And what's 3 times 5? Okay, so this turns into 15 root 3. Cool? Okay, so now I want to do the same thing. I'm going to simplify this one. And I'm going to see if they might end up matching, in which case I could put them together. So I got 48. It's still square root. I need perfect squares. Do you have any perfect squares that go into 48? 16 and 3. So this is the square root of 16 and 3. The square root of 16 is 4. So that's 4 root 3. There's nothing else I can do with it, right? So I'm done with that. So this turned into this. This turned into this. So what am I looking at? I've got 15 root 3 plus 4 root 3. Are those like radicals? Oh my gosh, they match now. So I can pretend like they're a variable. I can put them together. What's it going to be? 19 root 3. Fantastic. Cool? Okay. 19 root 3. Okay. Why don't you try these two on your own before you dive in too much? What is a 1/2 power? It's a square root. So this is really 3 square root of 20 minus 5 square root of 180. These ones are cube roots. Just keep that in mind. So give them a try. So remember, 1/2 power is a square root. So I turn those into a square root. And then I'm going to, listen up, guys, listen up. I'm going to look at them one at a time. Bless you. I'm going to look at them one at a time. Do you have a perfect square that goes into 20? 4. 3 square root of 4 times 5, okay? Look at it individually. Square root of 4, square root of 5. What's the square root of 4? So this is 3 times 2 root 5, and 3 times 2 is 6. Okay, so that turned into that. Are you okay with going from there to there? Yes. And let's look at this one. I need a perfect square that goes into 180. 36 and what? And 5? So again, guys, if you're not sure, if you don't know how to find it, get out a calculator, start doing 180 divided by these numbers until you get 1, okay? In this case, it's 36 and 5. So this is 5 times 36 times 5. What's the square root of 36? So it's 5 times 6 root 5, and 5 times 6 is 30. Yep, so we're subtracting. You got to be careful here. You're subtracting these things, right? So it's this minus this. Can you have a negative? Is that okay? Yeah. What's 6x minus 30x? Negative 24x. So this is just going to be negative 24 square root of 5. Because you got the like radicals. They're both square root of 5. Treat it like a variable. Combine the numbers, and you're good to go. Cool? Feeling all right? All right, do you have any lingering questions about what's up here right now? So a 1/2 power is the same thing as a square root. So I just turned them into a square root, okay? Are we okay? Okay. So I only have one more thing to show you, and then I'm done talking at you for today. Not too bad. All right. Okay, one quick thing, guys. This is not going to come up for us a ton in this class, but if you have intentions of taking like a college algebra class, either here at Rocky or maybe if you're planning on going to college, you'll have to take something like that. This will come up more. It won't come up a ton for us, but I just want to show it to you. Rationalizing a denominator. What do you think that might mean? Well, first off, what's a denominator? It's the number on the bottom. What's in the bottom right now? A radical. All right, so over the course of this class, we've talked about a number of things that if you do them, you will be promptly shipped off to Calcatraz, all right? Well, there are some things that just happen in math that if you let it happen, or if you do it, you're getting locked up in Calcatraz forever. Yep. So one of those things is having a radical in the denominator. That's a big no-no. We don't like that, okay? We do not like radicals, radicals in the denominator. No. Sad. Don't like it. Somebody's going to call the KGB math version and get you locked up. I was trying to think of a pun for that, but Maybe the ABC or the XYZ or something. So you can't have it, all right? If you see a radical in the denominator, it's bad news. Here's how you get rid of it, all right? Here's how you fix it. It's a pretty easy fix. If I have 5 over the square root of 6, and I want to get rid of that, all I need to do is multiply this thing by the square root of 6. And whatever I do to the bottom of a fraction, I also have to do to the top. What's the square root of 6 times the square root of 6? It's 6, right? The square root of 2 times the square root of 2 is 2. It's like undoing a square, right? Undoing a square root. So this is going to be on top 5 root 6, and on bottom we're just going to have 6. I can't simplify those numbers. I no longer have a radical in the bottom. So this I feel much better about. Yes. That's kind of weird. I don't know what to do about the eyebrows. No. Okay. That makes sense. If you have a radical in the bottom, that's a no-no. So to get rid of it, you rationalize the denominator, which means you multiply it by itself, by the radical, and then it goes away, and you're all good. Cool? That's the gist of that.